So yesterday we discussed about uh, the Spark functionalities and all right. So today I will continue with the remaining one and then maybe take the next thing. So to make the reference with the same yesterday's class, I will just repeat with the UDF where this was the data and this was the schema, and here we had two data frames. One was for orders data and second was the products data. Products data is the CSV data. Today we are going to work with this. Then quickly go to the UDF one. In UDF, we have this function. For this function, we need two input parameter. This, if you are, let's assume that this is a simple function, Python function, and you are not using any UDF. Then simply we can call this function like this, print and price equal to 10, just we can assume, and quantity equal to 20. And here, sorry, this is the function parameter. Here I can give calculate total number, and this is done, right? So simply if you have to use this as a function, then you can give this a function name and then you can pass the parameter value. This is the price, this is the quantity. And if you are working with PySpark, then same function we can utilize as a UDF, user defined function, where we can do whatever we want to, because most of the functions are available with Spark. Simply you can use that. But if something is not available, some logics you want to implement or you want to do, but that is not available with the Spark, in that case you have to develop a function. You can have your all the logic, whatever you want, then you can return the expected output, and finally you can register as a UDF and you can call that. Here we are doing the same. So we are registering a UDF with this name, total cost UDF. With UDF keyword we have imported this. This is our function name and this is return type. Once this is returned, then we are using this. We can use this, like here I am taking bit column. This will be the new column name, and for this new column name, what will be the value? So the value will be output of this value and this function. Okay, whatever we have created here. So this is total cost UDF, and then input parameter. So input parameter is column here. We have given column COL. So this will understand that, okay, for this UDF, you are passing that two parameters. That's the column name. And if you do not want to define a function and then register that, then as I had said, with this way also you can at the rate UDF and then whatever return type you want and have your function. Now this function itself is going to be have as a UDF, and here you can call it directly. No registration is required now, means additional steps are not required, and you can have your input parameters. The number of columns can be there 1, 2, 3, 4, 5, whatever. Either you are providing the column or maybe you are providing some literal number, some default value, anything can be. Okay, and UDF we mostly use whenever we do not have a function available with the Spark. Make sure that this is not much optimized, because whatever coming with the Spark, that is much optimized. That multiple things has been taken care. And here you are developing it, you are implementing it. So make sure that whatever you are doing, that is optimized, that is going to have your processing faster. There is no blocker, and as this is a row level operation, this is going to process your row level data row by row. So this is a kind of time taker, you can say. This will be a time taker process and not much optimized. So whenever really not required and you have the alternate options which is available with the Spark, always you should go with that, because any function which is developed by Spark, which is available with the Spark, that is always better. Okay, so this way you can have that. Now we need this two column also, right? In our data, these two columns were not available. So here exploding this order data frame where we are selecting all the columns. Fine. And finally, Here I have used some different function from yesterday's one. I have to that column map column were there, right? This was um, price map where we have key value pair data. So this is the product P1, P2, P3, and this is the price for the product. So here what I am doing, I have used a post explode, not the explode. Yesterday we seen the explode. Explode was also working. Explode was working for exploding the value from the nested structure. Post explode is also same, but it is having. You can see here one word is pose. That means this is going to have index as well. Okay, along with the data. So this will be exploding, and along with the exploration, it is going to have index, and based upon the index, this will be working. So here I am from the product column, I am doing this. Here is the product. This is the product. Product is kind of array list of the data. Okay. So from list of the data, here with Poj explode, I am exploding with the product's name, and this product is the column name. This product is the actual column name. What is in the column name or key in the JSON data, and this will be returning two columns in output. One will be push. You can give any name. This is alias. This is by default, and this is the product. Two columns. This is going to return. Okay, and then from the price map column, we need to get price column. So price column we can get based upon this product. Okay, here if you come to the data, we have product. So if you have the product, then for this product, what is the value, and for which product, what is the price? For this product, what is the price like that. So first we have exploded products from the product from the products column with indexing, and based upon the product, we are exploding this price column from the price map. So like that, we are getting price and product both at the column, including this position for indexing column, and then we need quantity column as well, quantity data as well. So for quantity, again based upon the indexing, okay, I am exploding quantity from the quantities column. Here is the quantities column. This one, this is also list of numbers. This one, right? Like that. So our required columns are ready. We need two columns as input parameter, price and quantity, and both is ready now. So we can have that. Next, I will simply print that. Let me uncomment all one by one. We will see quickly. Okay, I will just run for the UDF one. We have two UDF. UDF means UDF is single only. Just I have created with the both types. One is by registering, one is direct returning as UDF. Okay, and this is exploded orders DF. So in exploded orders DF, we can have, okay, I have not commented out this drop duplicate. We will, I should comment, I guess. Okay, no need. Here, just take the original one, and this one. If you see here, this is having pose 0, 1, 2, 0, 1, and 0. This indexing you are getting along with the explode. This view we're not getting when you were doing explode. Okay, so explode is a very favorite question in interview and all. Why? Because people want to understand how you will be working with the nested data, because nested data is a very common thing. Always, most of the time you are going to work with XML and JSON, and there without nesting means it can have straightforward data also, but most of the time you will be having nested data, and you have to work with that. So you should have idea how you are going to work with the list, array, map, key value type data and all. That's why this is there. Now, if you want to work with the indexing models and all, you want the index for the explode, whatever you are doing, then you can go with Poj explode, and this Poj is going to create index for you, and this will be making your task a bit easy. Okay, so here if you see 012, 012 means for customer ID or product order ID, if you see 001, this is 3 times. So this is started from 0 and 012. And indexing is breaking here. For another order ID, indexing is again starting from 0 and 1. And for another order ID, indexing is again starting from the 0. That means this position is for each of the unique product, right? Unique order ID and all like that. If you look at here, Poach products. Okay, yeah. So as we had given for the according to the column name, this is happening. Now we have got product. This product was created based upon this products column, and based upon this product, these value were extracted from this price map column. This is the quantity. Quantity we got from here 213, 213, 213. So we have got here I have dropped the duplicate. If why I dropped duplicate, because I see some duplicates data. Okay, duplicates records. Why duplicate records? Because let me uncomment this and run this again. And while you are dropping duplicates, then you can have a set of columns, because if you are giving single column name, maybe that is not removing duplicates properly. If you think that duplicate should be removed with the combination of some columns, that if this is also unique and this column is also unique, then otherwise, let's say for one of the column, there can be duplicate, but if you do the combination, then maybe that is a unique value and not the duplicate, actual duplicate. That's why. So if you see here, if I am not going for the duplicate one, I think output is same, right? 012, 012, 123. Yeah. Anyway, there is no duplicate. So, if you have something, you can put it. If there is any duplicates and all, it will get removed. And then 2, 1, 2, 3. Okay. Then we have this one. This one was the our UDF one. All right. This is order cost. You can see total cost has been calculated. Price into quantity. So price into quantity. This, sorry, 500 into 2,000, 300 into 1, 300. And this should be here as well. So for both of the UDF print, this is output is almost same. You can see here. Now this post column is still there, so I will drop it. Here I have this one, exploded orders DF. Okay, so I am just going to drop this column name. So next going forward, we will not be getting it. Then let's move to next. Next is this, join the product data. So if you see now we do not have that purge column, that's gone. Next, join the product data, where we want to join the products data frame to enrich the order data with the product detail. This is the product data. In product data, you can see we have 3 columns: product ID, product name, and category. So product ID is common. Here we have products, right? Products is having 0, 1, 2. So here it was a list of product. You have to explode it. Anyways, for the previous switch cases we have already exploded, but let's assume that if it was a new requirement, fresh requirement for you, then you have to explode from this list, then you can go ahead. Means we will be having a unique column name in both, which we can use for joining. Then product name is some devices, and then category. What is the category for that? This is electronics, this is supply chain. You already know about the orders JSON, and we have already data frame for both. Now coming to join details order. We are simply taking orders with cost. Orders with cost means this is just our previous data frame, which we created using this UDF. This one, right? We have called our UDF, total cost UDF. This is orders with cost. I'm just taking that data frame, then join with products DF. Products DF is your CSV data. We have already read in the above step, and we have did that. Then orders with cost dot product equal to products DF dot product ID. Okay, and orders with cost and then dot product ID. Where is product ID? Products DF. Products DF is having product ID. Okay, so this is having product ID column. So it is saying that we have already exploded product column in the orders data frame, and here for the products we are taking product ID and we are joining with left. Then finally we are getting these columns we want, and then let's print it. We want to select these columns after join. If you want all, then no need, simply print this. Okay, but as I want to select and I want to have a order for the column, so we can go with this, in which order I want the data after the joining. So there select will be helping you. So here you can see, if you want to go with the Spark SQL, you have to write your select star from table A, join table B, then table A dot column name equal to table B dot column name, right? But here simply you are giving this data frame dot column equal to another data frame dot column. Then what is the join type? That's it. Here if you see order ID, customer ID, products, uh, then I think some other data frame is also getting printed. Okay, no issue. This one. So this is having order ID, customer ID, products name, category, quantity, price, and total cost. Here we are getting after joining. If you see, category and products name are there after joining. All data has been combined. Means after joining, both the data frames data is all together. Then come to the next one. In the next seventh step, we have column function. So this is simple. We have already used column functions, right? So that simply I have repeated that. This is our above data frame detailed order. Then group by order ID. We are just grouping with the order, and total cost. We are just taking with column renamed. We want to rename this total cost column as order total. Okay, and again we want to do the filter where this order total what we got after rename is greater than 1000. So here in this step what we are doing, group by order ID, then sum total cost, and rename the column total cost to order total. Then we are doing the filter. If I am going to do this, so then what is the output? I think somewhere else. Okay, this is getting printed. That's what I will say. Okay, now it will be fine. Okay, here if you see, it has been filtered out with greater than 1000. Okay, and you were getting two columns which you used for group by order ID and order total. Means this column is now first it had this column, then we renamed this. Then if you want to get all the columns, this is getting only two columns. If you want to get all the column, then this option you can enable where you join with the original data frame to retain all the columns. Original data frame means this one, details order. Okay, and order total. So this one you are getting after doing this calculation. Okay, and this one is your original one. So we are again we are just trying to retain all the columns. So detailed order equal to detailed order. This one our original one, and then this is what we get after joining after doing this mm, calculation. Okay, then again we are joining it. If I will print now, then it will be having all the columns. So you can have your use case and all whatever you want to return. If your requirement is just 1, 2, 3 columns, whatever you are using here in your aggregation, that is fine. If you want to retain all the column along with your calculation and all, then you can take this one. You have to just join back with the original data. So this one order
We are
totals.
after joining, we are filtering from the previous data frame.
Where filtering?
Order total greater than 100,000. So I think we need to do it
No,
before the joining with the original data frame.
no,
First, we need to
this
filter,
is not
then join.
this is no, this is fine. Filter means this is just the value, right? Row will be less, but it will be okay. The problem is here. I am just printing the previous step only, what we had, and this is here order total. We enabled this line, right? So now it should be here, correct?
That is why I'm asking that this line should be above. This line should after the joining. Right?
So you are saying do not filter.
No, no, no.
Okay.
We need to filter, but after filtering, we need to join with the original data.
Anything we can. That will be more better for the optimization point. Because if you first filter and then join, then with the filter, some records will get reduced from the original one, right? So you are suggesting this one, right? Keep this first, and then high value orders.
Yeah. And when it's replace the order total.
Then
Detail order dot join under order totals. Instead of order total, we need to mention high value orders under the bracket. Yes.
then we are printing the same. No, this one should be in print.
Now it should be fine.
So we have all the columns plus filter we already did in above step. So nothing is having less than or equal to 1000, right? This was greater than 1000. So all values are greater than 1000 only. Next we have this step for the array and map function. Perform operations on the array and maps. Check if a specific product is in order or not. Order means order column. Okay. We have this Where is this? We have a data frame where we have this products, right? So these are the orders. Here, just I'm creating one. This is our original data frame, and I'm creating one column name. Contents desk. Array contents. Okay. Array contents call products, and this is the products. This one, anything you want to check, either that exist or not. If exist, then it should be returning as true. If not, then it should be returning as false. We can check for any. If we see for 3, then for order ID 1, 3 exists. For order ID 2, doesn't exist. For order ID 3, 3 exists. That means for 1 and 3, it should be true. For 2, it should be false. Let's go with this. And okay, if you see here 1, 2, 3, this one is having 3, so this is true, this is false, and this is true, right? If I say 4, 4 is existing only with order ID, order 2. Order ID is having 0000002. This is having 4004, and remaining 2 is not having. So it will be returning accordingly. So like that, if you want to check kind of a specific data, either that exists in this proper particular column or not, then you can do this kind of things for the test cases as well. Whenever you are doing development and you want to do some kind of validation, that then this is going to help you. Or maybe based upon this data you want to implement something, okay, that if this kind of data exists, then only do this, otherwise don't do this, return this default one, or just exit. In that case also you can use that. Here you have array contents. This is already defined function. You can utilize that without having your own function to check the data. Again, if you want, you can create your own function, you can implement, you can register as UDF, and you can do the check. But if we have already available, then why to do that additional things, right? Now if you see for the 4, this is true because it is having this resistance, and for remaining 2 there is no 004, so this is returning as false. Now, I will be coming next. For the price map, that was the key value data. And in that key value, yesterday what we see, we had did with the map keys and map values, and we had directly we used with explode. With explode, that was returning in the duplicate kind of Cartesian product, right? It was matching each one with each one. Like if we have a P001, then this P001 was getting matched with 500 also, 300 also, 1500 also, like that. Like this one was getting returned with all 3, this one also getting returned with all 3. So it was having kind of duplicate, but we can change the behavior. Just don't use explode. Simply, if I will go to the yesterday's code, I will tell you where it was. Yeah, here we had map keys, and with before map keys we were using explode. Map values we were using explode. Now different means you will be getting the different behavior. Even you can try that out. Now I will be doing the so without the explode, then you can check the output. So I just wanted to say that we are having lots of way to do, and these are something which is very much required to know, because real time data will be like this only. You will be having complex data sets and all, and you have to work with that. Okay. Then here I have given this key and value. If I do the copy paste from the yesterday's one, and if I print the quickly, then you can see what was actual differences, what actual difference we are getting. Then it will be more helpful. Just let me print here. Then you see how that is behaving with explode, how, what is the behavior, because everything is same, and without explode what is the behavior. So here our expectation is just extract the key and value, nothing else. Okay, and here our intention is to explode the data from this price map column, key column and value column. This will be the key, this will be the value column. Now let's see this, see the output how it is, means what is the differences, then we will be understanding better. Because see, in some of the requirement there can be a condition. Okay, this is the map data, this one, extract all the key and all the value at a place. Not like this is the map, this is the value, this is the map, this is the value, not like that. Just key one side, key at one place, value at one place. So for that kind of use case you can use it. If you see the output here, we had, we have taken the first one with the explode. What you are getting for P1, this is getting map with all three, right? For P2, this is getting map with all three, P3 also same, then P2, P4, P3. So this is just trying to map each one with each one, kind of Cartesian product. Okay, and this is extracting two columns, this key column separately and value column separately with the mapping. Here, when we removed the explode keyword, but complete syntax is same. It's completely different. You see the output, what it did. It in product keys, this has just extracted the keys from the data, right? So most of the time we have the requirement for the key itself, because based upon the key we want to do something. Always our output is not required to be in this way only. We can have different requirement. So here, if you see, it is returning the entire key from the data, and that key is coming as a list of key. Okay. So again, if you want to work with this, you have to explode. And for the product price, it is collecting all the values as a list of value. Okay, that means if you are using the explode, your output is getting returned like this. And if you just want to collect the key and the value as list of key and value, then you are simply good with the map keys and map values, and this will be returning, this will be fetching the entire key and value, and it will be returning as a list. So that is what we got here. This was the map keys and map values. Okay, this one we see, right? Fine. And now I hope that this is better, and you are understanding the context why I am explaining and when you will be using this. Okay. Then come to the next. So you can see that with simple things how its context is getting changed. Then same I have tried to explode, this context is different. Here if you see the output, we are simply getting this key value and all, and when we use the explode, then we are not getting the exact output. Yesterday also we had discussed this, we are getting this one. Okay, we had used the select yesterday in yesterday's example. Now I have just did this, I just debug yesterday what issue we were facing. So I got that with that indexing one, still I got the issues. It maybe because of his Spark version or Python version, or that is not supporting, because it was supporting previously. But yesterday I tried to debug. Still I see the issue that was not resolved. Maybe some enhancement, some changes has been implemented. That needs to check. But I got the alternatives with the key value itself without the indexing one, where I here I am using map interest. If you see, function is changed here. What this is going to do is I'm just trying to flatten this column, price map column. I just want to get the key value pair, but not with the duplicate Cartesian kind of what we are seeing here right now. So with map interest, but this will be working only if your data is kind of map data. Okay. and price map. Price map column, we are getting this price map data, and from that price map data, what is key and what is value. Key we are taking as product name, and the value we are taking as product price. And then finally I am dropping this column. Here I will be printing this column itself to see how this product map data is in output. Truncate equal to false. Okay, then here we will be getting name and value. So from this output, we are extracting key as name and value as price, finally dropping the flat map data, original data that we do not need, right? And then even I have to drop duplicate. I will let me comment it out and do the so.
Truncate spelling is incorrect.
Which one?
In line number 130.
Truncate is spelling. Okay. Truncate, yes, it will be failing. So let's rerun. You are having very good debugging skill, Naresh. I like that. You capture each and everything from the corners. That should be with everyone. Then we avoid lots of errors, mistakes, and all to get at the last. We can see that, okay, from 30 minutes my job is running and finally I got failure. Then that's again I have to rerun, right? Okay. So if you see here, what was the output when I did this step? This one. I used map interest and I get this price map data to extract the key and the value. If you see, this was the price map column, and from price map column, after having this map interest, this has get extracted as this one. 0, 1, then 2, 300, then this one and this one. That means this is simply extracting key value, key value, key value in the simple way. It means this is just all the key and values has been separated, right? Instead of a single map, this has been separated with the each one. Then from the key, we are next in the next step, we are extracting product name from product map data, take key as product name and take value as price, product price. So this one is, this is the key, this is the value, and this one we are extracting as product name, and this one we are extracting as product price. So like that we can have our key and value pair. So this is just an alternative what we discussed yesterday. This here I am just dropping this to clean up the data, because this is not required once we are done with this, right? So just to clean the data. Then this drop duplicate. Do you see any duplicate here? You can check it and you can let me know if you see. 001. I do not see that. Do you see?
No.
Because this is to 300 and 300. This is duplicate. This looks duplicate, but order ID is different. This is for order ID 2. This is for order ID 1, right? So this is not duplicate. But if we have something, we can. And as I have given order ID also and product name also, even I can have some more columns. So if I say only product name, then it will come. It will remove the duplicate. That will be resulting wrong. But if I am taking order ID also, then it will match. Okay, this is same, but this is not same when we are comparing with order ID as well. Then our output will be
On
okay.
composite key. Yeah.
Right. We should always have multiple checks, because maybe with one of the column it seems like duplicate, but actually if you combine, then that's not duplicate. Order ID is different, maybe customer ID is different, but product name is same, right? Okay, then we have this one. Okay, same steps. If you want to do using select expression, yesterday we had it with select. I already said you that we can explore with column also, select expression also. We have multiple ways to do. With select expression, if you see, this is a very simple step, single line. You can see how your code got reduced, right? What you are doing? Simply orders df, then select expression. Star means you are selecting all the columns. Explode price map. This is the price map column. As product and price. That's it. Let's print it. See if it is okay. Then you can see that same thing you can do with this much only. No need to have the key and value separately. Means once you explode that, then you get key as the key column name, value as the value column name. Simply also you can do. Okay, so here if you see, this got all the column name, and then your product and price you are getting, right? That's it. So with the simple step with select expression, you can do this. Now we have last one. Last one is just a repetition. Final aggregation. Aggregation we have already done. Above one we did some order by group by, right? So this is the same. We have detailed order above data frame. Then group by category. Category we have in this product data frame. We have category and we have product name. So what we want to do, group by category and total cost, and then category total. What will be? Okay, so let me print this one first with the original data frame details order. Then we will see what can be after grouping by category. Okay, so this is the data frame where this is the detailed order data frame which we had got after joining. Let me go back. Detailed order. Here we had got it after joining. Okay, in the join state. So where we had joined both of the data frame. That's why we have product name and category both the column. Now what we want, we are grouping the data with category and doing getting one of the column total cost as temporary. Then we are renaming this total cost as category total. This is the total cost. Okay, total cost and then category total. Now you tell me what will be output of this. If you look at the category and look at the product name, if we are grouping by category, then for electronics, we have three, and for office supplies, we have three. So if we do this costing, then for electronics, what will be the output? Total cost is 1,300 and 300. It will be total 16, right? 1,600, and then remaining will get sum together. Let's see the output. And take this one as well. Okay, here if you see, let me expand this. Total cost, order total. So total cost group by category, electronics items 1,600, 1,300, 300, and remaining this one. So if you combine this value, you do the sum 4,500, 1,500, and then 1,400. Then it will be totaling to 7400. So like that we can get. So this use case was kind of a mini project, you can say, okay, where I try to cover some use cases, some transformations which you will be getting in your real-time data. I just try to relate with some JSON, some complex data which is having list map, and how you can utilize with the list map array, explode, extracting keys, values, and doing the joining, mapping with each other, and all like that you can. Now tell me, you want this code from me or you would like to do on your own? Then I will share, otherwise I will not share. I will simply share the use case. What is your preference? Anyone can speak. Why is silence?
Sorry, can you come again?
I am asking, we shared for this use case where we covered multiple complex things, right? So you want me to share only the use case and you will be exploring on your own, or you want me to share the code as well, what we have tried out yesterday and today?
Both can be fine from
You
my
want
side.
to
Yes, both
you
are
want to
fine.
do copy paste?
And
Okay, no
We
issue.
stuck somewhere now instead of Googling, so we can directly go there and save the time
Okay, fine.
on a positive note.
Okay, so I will share, but again, as I say, as I said always, right? Try to run at least once. So it will be, if not 100%, at least 50% it will be captured in your mind. And if you will not doing this, then you will forget after few days. Okay. Anyways, I will share the use case and the code file as well. I will combine yesterday's one and today's one, and I will share it. Okay, then moving next. So we are done with the transformation. We are done with most of the actions, some complex things we also explored. Now I will move next. Here I would like to cover this serialization and deserialization. At the high level, I believe that you all already understanding about
yes,
the serialization and deserialization, right? So in Spark side, this is providing serialization and deserialization uh, for the means we can utilize this where we are working with the distributed computing. Then this allow data to be converted to a format that can be transferred over the network or stored efficiently, where you can use lots of compressions and all as well. And in Spark, serialization refers to converting an object to a byte system, and deserialize again. Deserialization means it is a reverse process, converting the byte stream back to an object. Means object to the byte stream and a byte stream to object, and that supports further storage or transferring the data over the network. Where we have it is going to help you in the data transfer, in the caching, in the shuffling all the time. Because let's say you are shuffling the data, it means you are doing something and data shuffle is happening for 10 GB. If your data has been optimized by compression, or it is using some serialization, and your data is resulting now to 5 GB out of 10 GB, then of course your shuffling, storage, everything will be faster. Then default serialization in Spark. You are having Creo serialization, which one is available with Spark, and you can directly use that. So java.io.serializable, that is the default serializer, and this is flexible but not as efficient as other option. With the name of Java only, you can understand Java is not easy, right? This is really complex. If you are having the experience with Java, then it's okay. Otherwise, this is not okay. We have Creo serialization. This is faster and more efficient and alternative to Java serialization, but it is required to object. It is required the object to be explicitly registered. You have to register this. Okay, how you can enable this? So for the Java serialization, for the Creo serialization, so by default Spark uses Java built-in serialization mechanism, and any object that implements the serialization interface can be serialized. For the Creo one, Creo serialization is faster and more compact than Java serialization, and to use we need to configure the Spark application we are using, and optionally we can register custom classes as well. Okay, so we need to configure the Spark application to use this Creo, and optionally we need to register the custom classes to improve this realization performance. How you can enable this? This is simple. Whenever you are using the Spark session, right? Where you are going to create the Spark session, Spark conf, where you can provide the configurations whatever you want. So conf.set, and you can provide the Spark serializer. This is the key, and what serializer you want to use. So simply you can have your Creo serializer. Again, Creo is already defined with the Spark. You are not going to define how this needs to work. Simply you are enabling it with your configuration, and that will be available for the application. So that is also part of the optimization. We can register custom classes to optimize the serialization process. For that, classes to register and then Spark SQL rules. Okay, so this tells Spark to use Creo serialization instead of Java serialization. We can have the setups enabled with the conf set. We can provide the settings. Okay, then anyways, I have shared this document with you people. You can go through this serialization level. When you are having persistent and caching, we had discussed about the persistence that we have disk only, memory and disk uh, memory only serialization, and memory and disk serialization. This one also you can use. You already know that memory only you are looking for when you want to do all the processing with memory, when you want to dump some data with disk, and all the fitable data with memory to be processed, you are going with this. But if you want to do the same with serialization, you want to work with that persisting model also, and along with that you want to use serialization also, you can use this option instead of memory only and memory and disk only. Okay, what this will do, it stores the RDD or data frame in serialized format in memory. So this will be enabling one level additional serialization. For this one also, along with memory and disk, this is going to provide the additional setup serialization. So this is going to store the data in the serialized format. So you can use this. Okay, this is going to help you. Then here simply I have given the example. You can go through this. And then serialization data frames. This is just example. You should go. And then when to use serialization in Spark, when data is large. This is the main thing. If you have a small data set, then either your code is optimized or not optimized, doesn't matter. Let's assume that we were working with the very small two data sets. Does it matter if you write a rough code? No, because minimum you are going to have your one node cluster, right? Or maybe you are providing two nodes and you are providing some GBs of resources, like for the executor memory, at least you are giving 2 GB, 4 GB minimum. In that case, this is a few kbs data. What is the impact? Nothing. If your code is kind of rough code, you have not taken care of anything, nothing, no optimization, nothing is there, then also this will be working fine with the good processing speed. It will be resulting faster. Everything is fine because there is no data. Data limit is very less. That means data is kind of kbs. But same code will start failing if I will increase the file size. If my input file size today it is in KB, this is working fine. What if I made it 100 times, 1000 times more? The data is going to be more. My file size is getting to 1 GB, 2 GB and all. Then of course code will get slow because my code is not fine. So that time we need to take care. So that's why when data is large, we have to think about, because it's with the smaller data, you are not going to face most of the issues. But with large data, we are going to face lots of issues and mostly out of memory exception. That's a very famous and popular and kind of friendly exception, I can say. Friendly exception because it when it will come, we don't know. Whenever our data is going to be large and resources are less, simply we will be getting with a message that out of memory exception. Our this code has been failed. Okay, so serialization helps in reducing memory usage when dealing with large data sets that may not fit into the memory in their deserialized format. And during shuffling, when performing shuffle operations like you are doing joins, you are doing group by and all, then serialization is necessary to move data between the nodes. That can make your job faster. Persisting and cache optimization. When we need to persist the data using serialized form storage level, then we can use serialization, memory only serialization, memory and disk only serialization. So that will be helping minimize the memory usage. If that is utilizing 1 GB, then maybe that can be reduced to 700 MB, 800 MB like that. So if that is helping a bit also, then that's better. Then distributed processing. In distributed processing, objects needs to be transferred between the worker nodes because you are working in the distributed mode. So let's say that you are having 10 node cluster. Data is moving around between this one to this one based upon the data requirement, based upon the logic. So if you enable the serialization, that will be helpful because data size, memory occupation, and everything will be get optimized. Okay. Then you can, if someone asks about serialization, you can go through that, and of course this can be the part of your discussion. Java serialization, this is default with the Spark. It is flexible but less efficient. For the crew serialization, this is faster, more compact, but requires configuration. Whenever you are going with the Spark session, Spark configuration, you have to have the configuration registering the classes. You can have, maybe you are not running all the things, that is okay, but syntax level you can check it out once, at least try once, so you will not forget it. Okay, then different type of joins. I'm not going to discuss this in detail because already we have covered in our transformation, right? When we discussed about narrow and wide. And of course, if you are having a SQL background, then I believe that you all know about inner join, then left outer, then right outer, then full outer. So this is same. Here I have mentioned syntax as well, just for your reference. So you can go through this. Then cross join. This is Cartesian product, where returns the Cartesian product of two data frames. Every row from left is paired with every row from the right. Like we got from in the map cage map values, we were doing the explode, right? Like that. So for that, you can simply do df dot cross join df2. So df1 will be gets joined accordingly. Then semi join. This returns rows the left data frame table where the key exists in the right data frame but doesn't include in the columns from the right. How it works? This is like a filtering operation. Only return the rows from the left table and have matches with the right table. Performance wise, this reduces the amount of data transferred compared to a regular join. Okay, so see in interview, you may get the question what kind of joins you have used. If you are saying that okay, in transformations we do join, then there can be question. You are having some regular joins like left, right, full outer joins and down. After that, you are having some special to Spark as well. You should discuss about that. If question is coming around joins and all. Okay, you can show your expertise that you had this kind of requirement and you used this kind of join and how this was helpful. So in that you can include this semi join, anti join. Okay, where this returns rows from the left data frame table where no matches exist in the right data frame table. This is opposite to semi join and it filters the row that do not have a match. Then broadcast join. For broadcast join best for the cases where one data frame table is small enough to fit into the memory of other worker node. This broadcast join is most of the time this is part of the interview because whenever questions there will not be direct to question. Sometimes it can be direct to question. Sometimes question will be simply What is the optimizations you have used in your Spark application? That time you can talk about broadcast join. That if you are having a small data set, if you are having a big data set and you are working in a distributed model, you can go with broadcast join where it will be enabling a copy of that smaller data set that is fitable to memory to the nodes, and data shuffling can be avoided, and the data will all the process means as it is fitable into the memory, so all the things will be happening through memory, so it will be faster. So the smaller so this is the best for this use case is mostly best for the small enough data which is fitable into the memory, that is going to help you. It works with the functionality of similar data frame or table which you are having is broadcast to all nodes in the cluster and avoiding shuffling for the larger data frame. If you are having a big data set that is sitting to the different node for the joining, of course, that needs to communicate with the smaller data set. And for that purpose, that is going to shuffle. Data travel will happening from one node to another node. But if a data has been broadcasted to each of the node, then it will avoid shuffling, and at the same time, at the same place, same node, the joining will happen because it is having all the data. Performance wise, extremely efficient for small data sets because it minimizes shuffling overhead. And if you are good to avoid the shuffling and all, then of course your processing will be faster. How you can do that? You have to import this. Okay. SQL function import broadcast, and simply you can do large data frame, then dot join broadcast. This is the keyword. DF is small. This is your smallest data frame, and based upon which key you want to join, you have to provide that. So you can have question about the broadcasting and how you do the broadcasting. So this syntax you can have in mind. This is nothing very simple. You are simply doing the join and you are mentioning the keyword which is available with the function you are importing, and you are providing the key to join. That's it. Now coming to SQ. This is a complex thing in Spark. Anyone has any idea about SQ? What is skewness? What is the issue? Any idea? Single line.
No, no, Amit. Don't have idea.
No.
Okay. So here I will talk about this SQ join just after this join. Okay, in detail. So okay, in short, I would like to say, let's say you have 10 GB of data and you have 4 node cluster. What you are expecting if 2.5 GB data is distributed to all 4 nodes, then all will be having same resources, and similarly this similar amount, this will be taking almost a similar time also, right? This will be good. Now assume that because of some reason or whatever logic you had implemented, this got for one of the node 4 GB data, for one of the nodes kind of 7 GB, not 7 GB, some 5 GB data, and 1 GB remaining data is distributed amongst 2 other nodes with some 300 MB and 700 MB. What will be here? Which is having 300 MB and 700 MB, that is having proper resources, but it is not having that much data, and immediately within seconds this will be completing the process and resources will get free, right? And this will be sitting idle until unless your Spark application is running. Then for the remaining node which is having some more data like some 3 GB, 4 GB, 5 GB, whatever we had. So in that case, let's say you are having some 10 GB data and you have 4 nodes, node 1, then node 2, then node 3, and then node 4. For node 1, this got around 4 GB out of 10. For node 2, this got around 5 GB. For node 3, just 700 MB. And here 300 MB. What will happen if that was, and let's assume that your all the nodes are having some 10 GB resources you have given. Okay, 10 GB. What will happen? This is not having any, this all are having similar resources n1, n2, n3, n4, but data load is different. It is having only 700 MB, this is having 300 MB. So this will process the data very quickly, right? Then it is free because it is not having any data to process, and these are having more data. So let's assume that this is taking some 20 minutes to process, and this is taking some 30 minutes to process, and this took some 5 seconds, and this took some around 4 seconds. Then for remaining minutes, up to 30 minutes, this will be sitting free, this will be sitting free. That means resources are idle, they are not doing anything, no occupation. This one will complete the data processing bit faster comparing to this. Then this is also going to sit for 10 minutes, remaining 10 minutes. Because until unless all data gets processed, your Spark application will keep on running and you are not going to get the final output. So for final output, it all needs to wait for this completion as well. And this is going to take 30 minutes. Then after 30 minutes, all the output will get aggregation for this output, for this output, for this and this. So what was happening internally? These were sitting idle for the entire cycle. This was also sitting idle for some time, for few minutes. This was taking lots of time. Maybe there can be a condition where this creates a kind of bottleneck issue, and this is hang. This got hang or blocked. Or blocked means they are already blocked. They can't produce the output before 30 minutes. Even they have been completed within few seconds only because they have to wait for this. Okay, then hanging, blocking, kind of issues are there. Maybe this is lack of resources. This needs more resource, but this is not having, and this is having too much data volume to process, data share, whatever it has got. So in that case, maybe this itself, this node data can be getting failure. Okay, it is having memory issue. So this is not good, right? Our we can make sure that our data distribution, data share is fine. So it is getting processed in a smooth way. So that's the issue with the data and processing. Most of the time you will be having this kind of issue, and this happens mostly when our logic is not proper. We are doing the partitioning and partition by key, we use some key, we are doing the joining then after that, and whatever partitioning or grouping we are doing, based upon that along with the key, data is getting distributed, but data share is not happening properly. Because let's say we are having the data for India, for Pakistan, for Nepal, Bhutan, China. These are our neighbor countries, right? So if we talk about the data, let's say we are talking about the customer, mobile customer, in which country they are more. Of course, India and China are having more population, so they will be having good number of customer. If we talk about Nepal and Bhutan, they are very small country, so volume is going to be less. If we are comparing our neighbor country Pakistan, that will be also having comparable to much less, right? Then if you have divided the data, if you have partitioned it based upon the partition, some customer key and all, what will happen? On which of the node data is sitting for India and China, you can understand that that will be having huge volume, right? For the Nepal and Bhutan and all, very less data. Amount will be less, so that processing will be faster. So you have to make sure that whatever partitioning we're doing, grouping we're doing, how data is getting distributed, that is fine or not. Otherwise, that can create a issue for the processing time. So that happens, and if that happens are there, then you are. So this is keyword for that only. Anyway, we are going to discuss in detail after that. Okay. So this that was simply the concept for the skewed issue. Okay. When data is getting skewness. So the use case used to handle data skew where certain key appears more frequently than others, leading to imbalanced workloads across the workers. If you see here, data is not balanced properly. Data is having imbalance 4 GB, 5 GB, MBs and MBs, right? Like that. So how it works? Spark optimization techniques help redistribute the skew data And you can configure the SQL join handling by enabling the parameter Spark SQL auto broadcast join threshold and setting SQL joins detection properties. So if you feel that sometimes that kind of data distribution has happened, you can go with the SQL join. Performance wise, it helps to avoid performance bottleneck caused by SQL data distribution. And manual strategy, you can pre-partition or split the SKU keys to distribute the workload more evenly. If you feel that whatever I am doing in the implementation, whatever logic I am applying, that may go wrong with the data distribution, and my data should be evenly distributed across the nodes, then only I can get benefited. In that case, you can have some manual strategy as well, like if you are understanding the data and logics properly, then you can have some pre-partition or splitting the data based upon the keys and all. You can take care of that. You can have multiple ways. Then bucket join, this is also specific to Spark, and that is the part of optimization. And when questions are coming, what kind of joins you have used or joins in Spark, then you can talk about this. When people ask about joins in Spark, then what they want to check simply, they knows that you know SQL and most of the people are working with SQL and all. Then um, knowledge about the normal joins, regular joins, right? Left, right, full outer, and all. That is expected that you should know. But what is the additional? Additionally, you should talk about SQL joins. You should talk about broadcast join, bucket join, and all. That means you are showing your expertise that okay, I have used this also, and this was the purpose, and how my job got optimized. So this will be having a positive impression, and of course, you are going to get a good feedback if you are discussing about these things, because this will make you unique amongst multiple. Most of the time you may see okay, we are interviewing 10 people, then 10 people are all are good, no one is kind of dummy resources. Then how we decide, we think okay, okay, who is unique, whose response was unique, who was responding in a better way, we are going to decide about that candidate, right? So like that it works. So bucket join, so this is bucketed sort merge join. Use case wise, this used when both data frames are bucketed on the join columns and have some numbers or same number of buckets. For this bucket join, your data should be bucketed. And you know the concept of partitioning and bucketing we had discussed in deep, right? So bucketing means your data will be distributed with n number of buckets uh, with equal amount, almost equal, not 100% equal. Like if you have 1 GB data and you were saying bucket 3, then around, or let's say for make it simple, bucket 4, then 250 MB, 250 MB. Accordingly, for a complete 1024 MB data, 1 GB data will get distributed, right? And you will be having control also over the bucket. So if you're before applying this join, your data frame or table wherever you want to, that should be bucketed in advance, and it should be having same number of buckets. How it works, if two data frames are bucketed and sorted on the join key, Spark can skip the shuffle operation, leading to faster joins. This will be helping you to join the faster. And anyways, if you have sort merge join. Sort merge means what? When you are applying the bucketing and all, your data is getting sorted in advance. So whenever shuffling happens, then along with the shuffling, this does sorting as well. Then it is going to do all the aggregation. If sorting is already done, then that is going to be skipped. Bucketing is done, then for bucketing data is divided means kind of equally with equal volume with the nodes. So multiple benefits we are going to get. So this is going to skip means mostly along with the all the implementations and all based upon the logic, this will be skipping the shuffling operation, maybe not 100%, but of course that will be reduced and leading to the faster joins. Performance wise, very efficient if data is bucketed correctly beforehand. Okay, how you can use that? If you have already, then data frame 1 dot write bucket by 4 based and the column name, and save as table. You want to save as table, then table. If you want to save as file, you can have that keyword, and accordingly you can do that. Then next one, sort merge join. If you see here bucket join, here also I have given this keyword. Okay, bucketed sort merge join. If you are using sort merge join, then this is not a keyword kind of thing. This is just a logic. So default join in Spark when tables are larger and data is not skewed. How it works? Both data frames are sorted on the join key and then merge. First, and anyway, anytime when you sort the data in advance, then always that will be having the optimization because already data is sorted. Then if anything you are doing, then that is not going to do the same steps again and again. That is already data will be accordingly distributed and it will be working out. So if both data frames are sorted on the join keys and then merge, so requires shuffle or of data if not already partitioned on the join key. Performance wise more efficient than a hash join for large data sets if properly partitioned and sorted, but requires a full sort of data that is required. Okay, you have to check out. And if you look for the syntax wise, then this is simply your inner join only, but you have to take care for the sorting and okay. Then you have shuffle hash join. For shuffle hash join, uh, best used when both data frames tables are small enough to fit into the memory, but are too large for the broadcast join. There can be a condition, right? For broadcast, what happens if you have a small data set, you have a bigger data set, you are good to go with broadcast. You can broadcast the smaller data set. But what if both are small, but both are not as small that it is good for broadcasted, but both are smaller? In that case, you can think about this. So this is best used when both data frames are small enough to fit into the memory, but too large for the broadcast join. Because for broadcast joining is having also some limitations. This is 1 GB, 2 GB. It is good if you are going by maximum with 2 GB. And that works very well if you are having the data in KMB and MB. Okay. Then how it works? Both data frames are hashed and shuffled across the nodes based on the join key and then joined on each partition. Each partition in the sense whatever tasks has been task means unit of data, right? It is creating the stages, then it is creating the task, and so it is going to join for each of the partition. Then performance wise, faster than a sort merge join above one. This one sort merge join means by default your inner join where you have sorted the data. It means you can sort the data in advance. So this is faster than a sort merge join when data sets are small to medium size but still require shuffling. That means data is not too much small that it can be completely you can go like broadcast join, and it is not larger also. So you want to do some optimization and it is kind of medium size, small to medium, and it still requires shuffling. That will be the requirement. So in that case you can go and performance will be better. And here Spark automatically choose hash joins for small medium data sets, so no manual implementation is needed. Anyways, Spark is defined in a way, it is designed logically that it auto detect the requirement, okay, what we are doing, how much resource it needs, what can be the better internally, how what optimizations can be applied. Spark will take care. So for this also, Spark automatically choose hash joins if small data sets or medium data sets we are providing. So no manual implementation is required here, but this is just a concept. And again, if you want, you can implement your own logic for the same with the same concept, same logic, and you can apply that. And of course, that will be helping you. Then partition pruning. This help reduce to amount of data read by pruning unnecessary partitions during a join based on the filter criteria. If the data is partitioned on a column, Spark can skip irrelevant partitions when joining by partition column. Let's say we are having partition column partition by country and country is having some 100 plus countries. We want to go with some 4, 5 or selective 10 countries only. Then what is the need of going with all, right? So if your data is partitioned and then Spark can skip irrelevant partition, which is not required when joining is required. Performance wise, it can significantly reduce the amount of data read and processed, improving the performance. How you can do that? You can simply, whenever you are reading the data, let's say my source data is Parquet. I am reading spark.read.parquet, then my file path, wherever it is. Then during read only, I am applying filter and then partition column equal to whatever, let's say country. Partition column name is country and here India. So what is the column name? What is the value? Partition value we can provide and then we can join. So when you are joining, let's say that your Parquet table, Parquet file contains 100 plus country data. If you are reading selected data only, then this joining will be of course faster, right? Because this is having limited data only, the selective data only. And if you are not doing the select and here if you are applying filter or fair dot fair country equal to India, in that case this got the entire data as source data and during join this is going to do filter, so that will be costly if you are comparing with this filter which you are doing while reading only. Okay, so this will be helping in the optimization, making the processing faster. Here I have the comment for each one, you can go through this one. Inner join, left right, left join, full join, cross join, broadcast, skew joins, and bucket, sort merge, and shuffle hash join. Then we have skew joins in Spark. Here, let's discuss in detail whatever we had. Before moving to this, anyone has any question? Anything?
No.
Okay, fine. Then, as we discussed about this skew joins, simply in a single line, you can say data is not evenly distributed across the network, across the clusters. If you are having data, you are expecting that it should be work in a distributed model, data should be distributed equally. So all will be having the fair share and they will be having similar resources, and means we have divided, we have made the resources available for them, right? And it will be having similar amount of data, then processing time will be also same and nothing will be having blocker or nothing will be going to queue or in the waiting stage, something or nothing is going to be the overload with the task and work and data. But that happens most of the times because of the data we are getting from the source. Always we do not have control over the data, but we have control over our logic, whatever we are implementing. So we can think about that. This is a real kind of issue, genuine issue, and you are going to face this. You have to take this challenge and you have to resolve this. And this is again a very tricky question in the interview about skew joins. Okay, what is skew joins and how you resolve this issue. And if you are good to explain, then I can say that if someone is good to explain about different joins, use of them, and kind of skew and all, then your feedback can never be negative because these are the questions which are going to decide that okay you are having deep understanding because everyone is knowing something, right? Everyone is learning, doing the exercises and trying their best, but these are the things which are making you unique. These are making to understand the interviewer. Okay, you are having deep understanding, you are having means your concepts are clear simply, you know, and if you know about the issues then you can think about the resolution also. If you don't know issues only, then what, how you are going to decide about the solution? Without getting the problem you can't think about the solution, right? We should know the problem first. So that are something, these concepts are going to be helpful. So in Apache Spark, SQL joins occurs when data distribution across partition is unbalanced, meaning certain keys in the datasets appear much more frequently than others. Like I gave the example for the customers and partition by country. So all the countries are having different number for the population, and according to the population, customer number will be varying. With the small country, that will be too much less, and for the countries which are having more population, it will be completely a big number. right? So this imbalance can lead to a significant performance bottleneck because some partitions will not have much more data to process than others. And these heavy partitions are referred to as skew partitions. Means which partitions are having more data, you are going to refer them as skew partitions. Skew joins can cause certain tasks in the Spark to take longer to execute, so they are forced to handle an excessive amount of data compared to the other tasks. And understanding and optimizing skew joins is crucial for improving the performance and Spark applications both. What is data skew? Okay, so data skew occurs when data associated with a certain key is not uniformly distributed and across partitions in the cluster, whatever we have, data is not evenly distributed and that is causing the issue. For example, if you are joining a column with keys like ID and one specific ID appears in a very large number of rows, then the ID will lead to one partition handling much data and one partition will be having less data. So that will be returning imbalanced workload and that is going to have a skewness issue. Then what is the challenge here? Challenges with this joins uneven workload since a few partitions have disproportionately large number of records, large number of rows due to the SQ key. Tasks handling these partitions will take longer and causing the whole job to wait for this slow task to complete. Like here, if you compare for this 300 MB, then node 4 completed within few seconds only. 700 completed within few seconds only. But you can't see the output of this. It has to wait until unless this is getting completed. This is also taking 20 minutes, but next 10 minutes it has to wait until unless N2 job is completed. So they are going to be in the waiting state. Okay, then memory and disk pressure. The large partitions can put pressure on both memory and disk, potentially leading to out of memory errors and or excessive disk input output of issues, related issues, stragglers. Tasks handling skew data might become stragglers. That means that is not moving ahead also, that is not failing also, kind of hanging, right? Meaning they can much longer to finish than other tasks. This delays can overall job execution time. So kind of stragglers that is taking lots of time to process and it is going to become a blocker for others. Types of skew. In the Spark, we have one is queue skew and the second is partition skew. Key skew when specific keys are more frequent than others, resulting in a large number of records for that particular key. And partition queue when partitions created by Spark based on the join key are imbalanced, leading to some partitions having much more data than others. So both can be there. Maybe because of the data where some key are there which is resulting to the more. And second one when Spark is doing when means when we whenever we are applying the joins and all and for the Spark partitions data is going to be imbalanced amongst all the nodes. Then how it handles. So Spark provides several techniques and configurations to mitigate the effect of skew joins. One is automatic skew handling that is enabled from Spark 2.4. Before that it was not there. Okay, it was there means concept was there. We had to do some additional steps. Our manual implementation we can say, but now it is enabled to have the automatic way. So starting with this version, Spark provides automatic skew joins detection and optimization. When this feature is enabled, Spark will automatically detect skew key and handle them properly. So now in the latest version, when this version got launched, Spark will try to detect if any uneven distribution is happened and Spark will try to resolve that. Um, if that is possible for Spark, because if that is possible Spark will take care, but if that is really uneven and too much volume too much for the partitions that is completely a condition where it is not getting handled properly by Spark, then you have to do that, you have to take care of that. So how it works if we are talking about the automatic skew, Spark automatically detects the skewed partition during the shuffle phase of a join. When shuffling happening, then it will detect, okay, for the node 1, this is shuffling for 700 MB. For the node 2, this is shuffling this much amount, and for another node, this is shuffling for GB's data. That means it's not correct. For the skewed key, Spark creates multiple copies of the smaller table and then joins each copy with the subset of the longer table and distributing the work more evenly across the cluster. So this is how Spark will be taking care internally if it has to take. Then configuration you can enable with the Spark conf. Spark conf.set, and you have to enable this Spark SQL auto broadcast join threshold -1. That is disable broadcast join if you want to enforce skew handling. Okay, and this one Spark SQL adaptive enabled. Enable adaptive query execution, that is the optimization available with the Spark. You are going to make it true. And adaptive skew joins enabled. Enable skew joins optimization. So if you are enabling all these things, then Spark will be good to take care, because Spark will understand that okay, you want to take care of this if this kind of situation comes. So Spark SQL adaptive skew joins enabled. This enable automatic handling of SQL joins in Spark using adaptive query execution. Adaptive query execution is for the optimization, processing optimization. But limitation is there. The limitation, this approach works well for two tables join, but might not work as effectively for multi-way join or complex queries. If you are having too much complex query, you are having tables more than two tables or data frame which you are joining, then maybe it may not result as you are expecting. So if you are having kind of medium data sets and median in the volume, and you have only two data sets, then you can go with this. This will be working properly. If not, then you have to go with the manual one. So this is kind of automatic. Second one is manual squeeze join handling. If that is not working out with the Spark default property, then how you can take care with Spark manual one. For cases where automatic skew joins optimization is not sufficient, or for older version of Spark. Anyways, this is just a comment, because nowadays if we right now we are landing with Spark 3.5 point some versions, right? Always this is coming with the next release. Then who is going to work with the this version 2.4 and all? I believe that I used 2.4 version lastly in 2021, I guess, or lastly, hardly I can say 2022 or 2021 only I can say. So now if I have to do something, I will never return to that version. If something is very specific to that version only, otherwise I am good to work with the latest version. Okay. So for the cases where automatic SQL joins optimization is not if insufficient, not sufficient, or we are working with the older version of Spark. So with the older version of Spark, that automation is not available. We can handle SQL joins manually by using several techniques. What is that? One is salting, key salting. So these are the kind of manual intervention. People may ask, what is SQL joins? Okay, how you handle this? Then you can talk about with the limitation, that this is the limitation of the medium, small to medium size data, and two data frames or two tables. And if you are enabling with this configuration, then Spark will be handling automatically. But if that is not the case, if criteria is not meeting, then may Spark not result properly whatever you are looking for. In case of much data, in case of complex queries and all, then you have to go for the manual intervention. And there, what steps you can take? So here, salting. For salting is a technique where you artificially introduce randomness into the join key to distribute the data more evenly across the partitions. How it works? We create additional copies of the SKU key by appending a random number. Means we handle that manually by appending a random number. Then we apply the same salting technique to the other table involved into the join, and this distributes the data more evenly across the partition, mitigating the impact of SQ key. So this is just a way to redistribute the data with the even data volume. How you can implement it? So for the implementation, simply you can go with the Spark function where dot with column I am creating a salted key column. You can have any column name. This is just for more readability. Okay. And then I am concatenating column join key, whatever I have, then literal value I am giving some underscore, then expression floor random value. So simply I'm trying to create one key, salted key column that will be unique. And then data frame 2 again I am doing, and then based upon the salted key we will be trying to perform the join, means simply a kind of uh, redistribution technique. Okay, data redistribution. So advantage, distribute the data more evenly across the nodes and reduce the burden on any single partition by spreading the skewed keys data. If all the data is available with a single partition or two partition, and the remaining partitions are remaining nodes are free, in that case this will be trying to redistribute the data, and data will evenly distributed across the nodes, then your joining will be better. But what is disadvantage? Increase the complexity of the code. Of course, you are going to do some additional things, right? And you need to know in advance which key are uh, skewed. Without understanding the problem, how you can resolve that? So you have to know very well. You have to analyze the data. What is the issue? Why this issue is, and which key is causing, which partition is causing the issue. If this data is not having this much, then what could have happened? So if your analysis is proper, then only you can do the good thing. So you need to know in advance which key are skewed, and then you can handle that properly. Second is broadcast join for the skewed keys. How you can do this? So if one side of the join is small, kind of lookup table, we can broadcast the smaller data set, and this will bypass the need for a shuffle altogether, avoiding skew. That means you are simply calling your broadcast join. You are thinking that okay, at the time of join, this is means because of uneven distribution, shuffling is not happening properly, or this is taking lots of time for some of the nodes and all. So if I can do broadcast join, then you can reduce this shuffle operations, right? It can reduce the shuffle data and all, and then it can make the faster. So here it is saying that this will bypass the need of shuffle altogether and avoiding skew, and broadcast the smaller data frame to all worker nodes, ensuring that all partitions have access to the smaller data frame. So here simply what you want to do, simply you want to do the broadcast, nothing else, whatever we discussed already above one, where you have taken the large data set, then a smaller data set you are doing to broadcast. So this is also helping in the data skewness. Then skew key replication. If you talk about this, then this is another technique to replicate the row associated with the skew key across the different partitions. And you can split the skew data into smaller chunks and distribute the load across the multiple tasks, where identify the skew key and split the skew data into the multiple partitions and replicate the smaller data set across those partitions to evenly distribute the work. For implementation, simply this is like a join only. You can go with this. This is the large data frame, and you are doing the filter based upon the join key and whatever the value is, and then replicate the skew data across the partition, where you can do skew data frame dot repartition 10, whatever you have. Okay, and then so here if you see, I have already this is skew data frame which is having equal means this is filtering with the value, and this is not non-skew data frame which is having I am giving the condition not equal to, and accordingly the replicated data frame we are doing for the skewed data frame, first one. Then join with the non-skew. Then here result non-skew data frame is there. Then you are going to do the join. So like this you can. Then union the result back together. skew, non-result skewed, union result is skewed. So because you have processed separately, then finally you have to union the result. Then for the best practices, here profile the data, what you can do better. So before optimizing for skew, it's essential to understand which keys are skewed and use Spark data analysis tool to identify skew data. That means monitoring can help you. Use bucketing. If you know the distribution for your join keys beforehand, bucketing your data can help distribute skewed keys more evenly across the partitions, and this is really very helpful. Okay. Then partitioning strategy. When reading the data from a distributed data source, then consider using the appropriate partitioning strategy, and this will also help you to avoid unnecessary shuffles and discord problems during the joins. Then adaptive query execution. As I said, you have to enable this in Spark config. So always enable adaptive query execution working with the latest model. Anyways, always we should go with the latest version only because that is having lots of benefits, lots of bugs are resolved and all. And allow Spark to automatically handle the skew in joins. Okay, so this is about that how you can take care for the skew joins and how you can resolve by salting, broadcasting, key replication, and all. Okay, anyone has any question? This document is uploaded. Okay, you can go through this. This is just okay. This one is narrow and wide transformation. This is part of this document. Okay, then all good, right? Or any issue? No, fine. Then tomorrow we will discuss about some Spark configuration, which will be helping you in this optimization along with the optimizations in Spark. Then we are going to start with building data pipeline. I hope that everyone has set up with the SQL in your local system, right? If not, please make sure that you are having the setup, and then we will start once that is done. Then maybe day after tomorrow we will be doing with we will start with Kafka. Okay.
Okay, so Anamika, which setup you are asking?
So tomorrow I am saying that we will cover the optimizations in Spark and some configuration. Okay. Then
Okay.
we'll start the building data pipeline with Spark with various sources. So let's say one source we can assume database simply.
Any
So
database?
you have database, you have some data in the database you are trying to read, then you are trying to do some operations. Finally, you want to write to the different target location. So if you have the personal laptop, if you are working with that, then you can have a setup. You can install any database that will be helping you, either
Got
MySQL, SQL, and all.
it.
Okay, and then for Kafka, once we are done with that, then we will do with Kafka for streaming and batch data set. So for Kafka, I will share the steps and all how you can install in your system, and then you can run with that. I will share the documents and all. And in between, I will share the exercise for today and tomorrow. I will combine. And please go through that because we have covered a lot with the transformation sections and all. Most thing is transformation and action, and in which condition we can use which one, which is going to be more optimized, giving more better performance and all. So make sure that at least you are doing all the exercises. Okay, fine then. I believe that all good. Then we can meet tomorrow in tomorrow's session, and by that time, have a good day. Bye.
Yeah. Thank you.